It is a cold morning in the Neander Valley, not far from Dusseldorf, in August of 1856. Quarrymen clearing a limestone cave called the Feldhofer Grotto strike something unexpected in the mud. Among the debris lie the fragments of a skullcap, thick-browed and heavy, and the long bones of a stranger. They do not yet know it, but they have unearthed the first recognized remains of another kind of human. The bones travel to a local schoolteacher and amateur naturalist named Johann Carl Fuhlrott. He suspects at once that they belong to an ancient form of humanity, older than any recorded history. In 1864, the Irish geologist William King gives this creature a scientific name, Homo neanderthalensis. From that moment, the Neanderthal enters the human imagination as a silent, stooped ghost of the Ice Age. But what did that ghost sound like? For more than a century, no serious scientist dared ask. The bones spoke of anatomy and diet, of injury and burial, yet the voice, the most fleeting of all human traits, seemed forever beyond reach. Sound does not fossilize, and soft tissue rots long before the skull is buried. The question began to take a scientific shape only in the 1970s. In 1971, the linguist Philip Lieberman and the anatomist Edmund Crellin published a study that would spark decades of argument. They reconstructed the vocal tract of the La Chapelle-aux Saints Neanderthal, a skeleton unearthed in France in 1908. Their conclusion was startling. The Neanderthal, they claimed, could not have produced the full range of sounds used in modern human speech. Lieberman and Crellin argued that the Neanderthal larynx sat high in the throat, much like that of a modern infant or a chimpanzee. A high larynx, they said, meant a short pharyngeal cavity above the vocal folds. That shape, in their reconstruction, made it impossible to produce the clear vowels heard in the words beat, boot, and father. The Neanderthal, in their model, spoke in a nasal, muffled voice, lacking the acoustic corners of modern speech. The claim was provocative, and it was quickly contested. Critics pointed out that soft tissue leaves almost no direct trace on bone, so any reconstruction of a vocal tract is largely inference. Other anatomists redrew the same skull with the larynx lower and the tongue reshaped, producing a very different acoustic result. The debate over how a Neanderthal throat was actually built has never fully closed. Then, in 1983, a new piece of evidence appeared in a cave called Kebara, on the western slope of Mount Carmel in Israel. Archaeologists led by Ofer Bar Yosef and Bernard van der Meersch uncovered a partial Neanderthal skeleton dated to roughly 60,000 years ago. Its skull was missing, but among the ribs lay something no one had seen before in a Neanderthal. It was a hide bone, tiny, U-shaped and complete. The hide is a small, floating bone in the throat, anchoring the muscles of the tongue and larynx. In modern humans, it plays a central role in the fine control of speech. The Kebara hide, examined and reported by Baruch Arensberg and colleagues in the journal Nature in 1989, looked almost indistinguishable from that of a living person. To many researchers, this was the first hard evidence that Neanderthals possessed the anatomical scaffolding for language. Yet the presence of a modern-looking hide does not, on its own, prove that speech occurred. The bone can be arranged in a similar shape in animals that do not talk, and its position within the throat is not fixed by the bone alone. Lieberman himself continued to argue that the crucial evidence lay in the base of the skull and the length of the neck. The hide, he cautioned, was necessary but not sufficient. The debate shifted again in 2013, when a team led by Stephen Rowe of the University of New England in Australia took the Kebara hide into a laboratory. Using microcomputed tomography and finite element analysis, techniques borrowed from engineering, they modeled how the bone behaved under stress. Their study, published in the journal PLOS1, concluded that the Kebara hide was not only shaped like a modern human hide, but was used in a similar way. The Neanderthal throat, they suggested, was built for something very like human speech. Other lines of evidence began to converge on the same conclusion. In 2007, a team led by Johannes Krause at the Max Planck Institute in Leipzig sequenced fragments of Neanderthal DNA recovered from a site in northern Spain. They found that Neanderthals carried the same version of a gene called FOXP2 as modern humans. In living people, disruptions to FOXP2 cause severe difficulties with the fine motor control of speech. The FOXP2 finding was widely reported as evidence that Neanderthals could talk. Later studies complicated the picture. Researchers found that regulatory regions around the gene differed between Neanderthals and modern humans, so the two lineages may not have used it in identical ways. Fox peatwoe, like the hide, is a strong hint rather than a decisive proof. In 2021, a study published in the journal Nature Ecology and Evolution pushed the argument further into the ear. A team led by Mercedes Conde-Valverde of the University of Alcalá in Spain examined the tiny bones and canals of the middle and outer ear in Neanderthal skulls from the site of Atapuerca. They compared these structures with those of modern humans and of earlier hominins from the same cave system. Their question was simple: what range of sound frequencies were Neanderthal ears best tuned to hear? Their results were striking. The Neanderthal ear, according to the model, was sensitive across a wider bandwidth than that of their older ancestors, and closely resembled the ear of a modern human. It was especially well suited to picking up the consonants that carry most of the information in speech. The researchers argued that this hearing profile would be pointless without a matching capacity to produce complex vocal signals. So what then might a Neanderthal voice have sounded like? Any answer is a careful reconstruction, not a recording. Some researchers, drawing on the shape of the chest and the depth of the throat, have suggested that Neanderthal voices may have been deeper and more resonant than the average modern human voice. Others, following Lieberman, have proposed a more nasal quality, with vowels less crisply distinguished. All agree that no one has ever heard the sound itself. A handful of scientists and artists have attempted physical or digital simulations. In 2008, the anthropologist Robert McCarthy of Florida Atlantic University worked with a speech synthesizer to produce a brief, computer-generated impression of a Neanderthal vowel. The clip lasted about a second and sounded, to many listeners, unremarkable, an ee with a slightly muffled edge. McCarthy himself was careful to describe the demonstration as a rough approximation, not a definitive voice. The wider question of whether Neanderthals had language in the human sense remains unresolved. Archaeology offers indirect clues. Neanderthals buried their dead, cared for the injured, produced pigments, and at sites such as Bruniquel Cave in France, arranged broken stalagmites into deliberate structures deep underground. Such behaviors, many researchers argue, are difficult to coordinate without some form of shared symbolic communication. Yet caution runs through the literature. Behavior can be complex without being linguistic, and stone tools do not preserve grammar. The archaeologist Francesco Derrico and others have warned against confusing what Neanderthals could physically produce with what they in fact said. The gap between a capable throat and a spoken sentence is, in the end, a cultural gap that bones cannot cross. What has changed, across a century and a half of study, is the silence that once surrounded the Neanderthal. The stooped ghost of the Ice Age now stands upright in the scientific record, with a hide bone in its throat, a modern fox peatwoe in its cells, and an ear tuned to the frequencies of speech. Whether it spoke of gods, of hunts, of grief, we cannot say. That it had the equipment to speak of something now seems very likely. And so, in the quiet of a laboratory in Leipzig or Alcala, a researcher leans over a fragment of ancient bone and listens for a voice that has been gone for 40,000 years. The voice does not come. What comes instead is a shape, a stress curve, a genetic sequence, a hearing range, each one a small candle held up to a vast darkness. Somewhere in that darkness, a Neanderthal is speaking. We are only, at last, beginning to imagine the sound.